Okay, hello everybody. I think we all should be here. Hold on one sec. Yes, okay, so it looks like everyone's here. So this is another one of our virtual coffee breaks, so feel free to come and go as you please. Go get a bathroom break, get a coffee break, get some caffeine in you. Unfortunately, being a virtual conference, we can't provide you free caffeine and cookies. But such is our lives nowadays. So if Cameron is here, I figured since there were so many questions to his fascinating talk, we could sort of keep that conversation going a little bit. And I'm going to just pull up what those questions were. So Cameron, whenever you get in here and settled and ready, just leave a note in the chat, and I'll bring you back up on screen. So just while we're waiting for that, a couple of quick announcements. So we have two research talks coming up next, starting at 11, following the theme of neuromodulation, building off of the type of stuff that Cameron just talked about. At noon, we'll have another one of our panel discussions. So the plan for that is for it to sort of evolve naturally. I was sort of thinking that since yesterday we had this, fantastic discussion between three, very established PIs about their journeys in computational neuroscience and their perspectives on things. It might be nice to use this next opportunity to get a little bit of a different perspective, potentially, maybe get some postdocs on screen talking about how they got their postdoc, how their, the early stages of the career has been, especially since so much of our audience here is graduate students and undergrads. So if that's something you'd be interested in seeing and hearing and asking questions more to current postdocs, if anyone who is a postdoc would be interested in coming up on screen and participating in that discussion, please let me know. You can, send me a quick email. You can say something in the chat right now. But I'm thinking that's what we'll do at the 12 o'clock hour today. The other just brief announcement style thing I have is that we're going to end today a little bit earlier. We're going to end the parallel sessions will end at 4:45 instead of 5. And we'll use those last 15 minutes as sort of a concluding session for the meeting. We're going to use that time also to sort of get a lot of your feedback. As you guys are well aware by now, this is the first CCNS. This is something that, we're all learning about this platform, about doing a virtual conference along with you guys. So we would love to get your feedback. We would love to hear what you liked, what you didn't like, what you think could be better, potentially if you'd like to see this conference return and sort of when you'd like to see it return, how you'd like to see it return. So we'd love to, get your feedback on some of that stuff, potentially have some interactive conversations on that. So that's the plan for the concluding remarks session that's scheduled for 4:45. So I guess I'm not sure. Let me see if Cameron is. So Cameron, it looks like you're in the session, so I'm going to send you the invite on screen. Feel free to, don't feel any pressure to take it right now, obviously. Go grab your coffee and take your time. Hello.
Hey.
Okay, so I figured we could use this time to ask a couple more of the questions. So
okay.
I put this in the questions and answers tab, and it got a bunch of upvotes if we're talking about Reddit speak. So I was sort of curious about your opinions on interactions with industry. That's something obviously that you've had a lot of experience with. That I think a lot of the people here may not have. Maybe something where maybe they're interested in transitioning to industry after they graduate or doing their research in an industrial setting as opposed to an academic setting. So can you maybe speak a little bit about what that experience has been like for you and what the sort of pros and cons are of that type of collaboration?
Yeah. So, yeah, I wish we talked more about these kinds of things actually in, academic forums, because it's really important. So I've always approached my academic career as my goal is to, and maybe this comes from more of the engineering training, right? I didn't do a neuroscience PhD, and so I came at it from maybe a little bit different perspective. But I've always thought, like, whatever it is I'm working on, it has to be clinically relevant within 5 years. And if it's not, then I don't really want to work on it. That's kind of always been like the thought process in the back of my head. And I can still be working on a basic science question, but it needs to have some relevance to something that, like, I know, like, if I answer this question, it's going to make an important contribution for me being able to develop a technology that I want to develop, right? So when you have that kind of mentality, then, and if you do actually want to see anything that you work on have any relevance in medicine, then the only way that really happens is through industry. And we can talk philosophically about whether or not that's a good thing or not. It's just the reality. Someone has to be able to monetize the idea for it to ever be able to be created into a product. And so now this is a new open source software versus commercial software. And shouldn't all scientific technologies or scientific softwares be open source and whatever? And that's a great philosophy, but it's basically putting a death pin into the software if that's the way you do it. Mm-hmm. And I'm just, that's just the reality. So, so there are many different philosophies about this. I, have decided that, I am Anakin Skywalker, but I'm not going to be, enticed by the dark side. I will use my powers to stay good.
The Star Wars references make me very happy.
Yes. So it's very hard to know how to walk that line. But, the world now, like I have, a conflict of interest management plan with the university, and, my time is worth money. So, like I charge the companies, a consulting rate, like I'm a lawyer. Just, it's like, this is what it costs. If you want my opinion, this is what it costs. And we can work together, and we can, bounce ideas off each other. And so that's one way. And that's the way the major corporations want to do things, right? They would like to hire you as a consultant to, learn about your technology and figure out whether or not that's something that they need to invest in or not. Or there's a startup route where it's like, you're trying to figure out how to help a small company move forward, and you might have technology that they can take and turn it into something, but they have no cash on hand. So how do you work with them? Well, you work with them by getting equity stakes in their company, and so that's a different approach, right? A different kind of conflict, because now, like, I have nothing from them unless they succeed. So now I'm incentivized to help them succeed. Mm-hmm. So a different approach. And like I said, I don't know what's right or wrong. You got to trust your gut, I think, a lot of times in this stuff. But there are many, many unbelievably smart people working in industry that academia kind of ignores. But frankly, they're the ones that are smart. They're the ones that are making money. Like, we're twiddling our thumbs working on these little things, getting paid, a third of our value. And yes, we can become famous for an idea, but trust me, they already had these ideas. So don't be thinking that you're, like in an ivory tower coming up with amazing thoughts that no one's ever had before, because you're not.
Interesting. Yeah, no, I think I appreciate your honesty on that question. I think that's something that a lot of people in our academic setting sort of, try to push off and not talk about the realities of that enough. So I very much appreciate that. So we have a couple more questions that sort of were carried over from the previous session. So this one says, I imagine developing the holographic interface in such a way that someone could zoom into the area of interest and adjust for electrode location and things like this, while also incorporating models that reveal the underlying circuitry. This probably speaks to getting a better understanding of the circuit you interface with, correct?
Yeah, for sure. That's the that's my dream. Like I love the concept of multi-scale modeling. It helps your brain put things in perspective, right? Yes, I want to understand what's happening at the molecular level, but I also want to understand how is that in context of, the neuron, the microcircuit, the big circuit, the cortex, and that's what's amazing, I think, about these kinds of new visualization tools. It allows your brain to process the contextual value of different levels of model and simulation results, and you can scale it all the way back to the subject, whether the subject is an animal that you're doing your experiment in, or the subject's an actual patient on the operating room. And so I just couldn't be more excited about the future of simulation and visualization in those opportunities.
Yeah, so on that note, there was a lot of discussion in the chat when you were presenting those really cool videos of the people sort of walking around that holographic image. So I was just sort of curious. So that video itself, I assume, was sort of was it some sort of like artificial crap? I forget what the.
No, it's just a feed from a third headset.
Oh, so that is literally what a third headset is seeing. Okay, I thought it was like one of those iPhone tricks where it was just putting that up on there, augmented reality.
And like the video quality actually is worse. The resolution now. So HoloLens 2 device. So all of those videos I showed you were with the HoloLens 1 device, which was I think released publicly in 2016 or 17. And then the HoloLens 2 device was released last year, and it's still very, very hard to get. But like, for example, the most recent stuff that we've been doing is all in HoloLens 2, and the resolution is amazing. Like it's much better than the videos that the video feed is reduced, and it's like I said, the videos are cool, but it's way cooler in real life.
Yeah. So, how intuitive is that? 'Cause you showed the one video of obviously the neurosurgeon sort of using it for the first time. Is this a technology where you think it's a state where you can just sort of hand it off to a neurosurgery group? Or
no.
So it does require a lot of training to sort of figure out how to manipulate these things at this point.
Yeah. So manipulating them is easy. So when Nader and Samir, started doing these first cases, they pick it up and it's like 5 minutes. They're like, they're going all over the place because then they've got their own like questions to answer, and they're like moving things around. And,
wow,
it's the easy part. The harder part is the integration of all of the pieces of the technology, right? And this is something that academics really, suffer from not appreciating the value, and this is what industry is really good at. So they're really good at systems integration and making it so that, the whole platform works from soup to nuts very, very seamlessly from the perspective of the clinician. And we're used to building software that's, I got MATLAB over here and, some other thing over here and Python script running there. And, you have to be a PhD to run the simulation, right? That cannot work in a clinical setting. I don't care how motivated the clinician is. That's not feasible. And so right now, the kinds of advanced simulations that we're running in the HoloLens, whatever, it requires a team of, engineers to make it all work. And, there's the big step of how do you take that and make it, actually seamless to the eyes of the clinician for mass production and, wide scale use. Like that's millions of dollars to make that happen, tens of millions of dollars to make that happen. And that shouldn't be minimized because that's really hard work.
So the challenge is almost on the proverbial back end of sort of integrating all of these different simulation environments and, challenges together.
That's right.
Cool. Okay, so a couple more questions here. So someone asked, how do you reconstruct axonal pathways without traditional DTI and functional imaging? Can this be done for individual brains?
Yes. So the way we did it, so there's the Peterson 2019 Neuron paper that, gets into this in detail.
People are very interested in that paper for sure.
Yeah, it's super. That was the most fun project I ever worked on. Like so much fun. So what we did in that context was there's tons of neuroanatomy from the 50s and 60s, kind of like dissecting out these pathways. And most of the people that worked on that stuff, they're all still alive, like they're just not computer scientists, they're hardcore neuroanatomists. And so they have all this knowledge in their brain, but they're not equipped to work in the world of connectomic imaging. It's just not their skill set. So the philosophy that we had was, okay, what if we bring those, famous neuroanatomists together and interactively, give them a holographic interface where we can reconstruct, we can take the histology data that's available in slices and whatnot and put it into a 3D, brain atlas. We use the CIT 168 brain as our sort of base. And then we overlay all this historical, histology data, and we bring in these neuroanatomists that actually collected that kind of data. And we now, as a group, we can all interactively see the same data and point at it and look at it in 3D as it courses through these, volumes of brain slices. And so that was what we did. So we used that to reconstruct a whole bunch of different axonal pathways in the basal ganglia, because that's, the big hotspot for deep brain stimulation. And, so it's an atlas now. You're creating a pathway atlas, but it's based off of, let's call it neuroanatomical expert consensus, and anatomical landmarks, right? There are known anatomical landmarks that you can see. And so how do you use the landmarks that you can see in combination with the histology data that you can overlay, in combination with the unique, kind of knowledge that's in the brains of those neuroanatomies? And so that was our approach. And I think that's a good approach for pathways that are just never going to be able to be reconstructed with tractography, because tractography, just has problems with certain things, small pathways that cross big pathways, pathways that make lots of bends, right? Those are things that, we all can accept that tractography can do an awesome job at reconstructing the internal capsule. It cannot do an awesome job at, the, lenticular fasciculus or pathways that are crossing the internal capsule, right? And so how do you, sort of think about alternative ways to do that? And like I said, this was one idea.
Awesome. Well, I think we have time for one more here before I'll let you go. So let me see. So someone asked, could you talk a little bit more about the long-term stability of the brain's response to deep brain stimulation?
Yeah. There are human beings that have had DBS systems in them and living for 20 years. And when they turn those systems off, and even in these advanced subjects, like their symptoms come back. Maybe not as robustly, maybe there has been some degree of neuroplasticity, and their disease has progressed. So, So sometimes they turn them off because they think that the DBS isn't doing anything anymore. Very late stage Parkinson's, but when they turn it off, actually it is still doing something. So this is, this is such a difficult question, because how can you be stimulating the brain for, at 100 hertz for 24 hours a day, 7 days a week for years on end, and not be doing some kind of amazing plasticity effect?
Yeah.
But yet you turn it off, and within minutes, tremor comes back. Within, hours, the rigidity is back. And it's like, or even faster sometimes. And it's like, how is this possible? I mean, to me, this is one of the greatest, scientific questions yet to be addressed in deep brain stimulation, because we should be doing amazingly more elaborate plasticity and modulatory effects, and it doesn't appear that we are. And so why is that? It's very interesting and unknown.
Interesting. So I guess that's the question for this next generation to start probing. Awesome. So yeah, so I will I'll let you go now. Thank you so much for sticking around and answering a few more questions. There are tons of them, so I might expect to see a couple emails later from people, because there is
I'm easy to find.
Yeah, there's a lot of interaction, a lot of engagement on this. So thank you so much, Cameron. I'm gonna sort of unceremoniously kick you off screen since there's.
Yep.
So again, thank you to Cameron. So we have about 5 minutes now until the research talks begin. So I'm actually gonna end this broadcast so I can go refresh my coffee. But again, just a quick reminder on the announcements I made at the beginning of this session, in case you missed them. First, for the panel Q&A session at noon, we're thinking that we're gonna sort of take a more of a young scientist, postdocs-esque route for that discussion to sort of provide a little bit of a point of differentiation from yesterday's conversation, where we had these great insights from our sort of experienced PI. So if you have questions that you'd like answered, if you're a postdoc that you'd be interested in coming up and participating in that discussion, please reach out to me via email or in the chat and let us know. And then the other thing, again, is if you can, please stick around this afternoon for that concluding remarks session, which is scheduled for 4:45 following the parallel sessions. We're going to use that to try to get some of your feedback on this new meeting. Again, we're learning about this just at the same time you guys all are, so it'd be really useful for us to get some feedback from you all as we sort of start to think about what the next steps forward might be in terms of a next meeting or something like that. So with that out of the way, I'm going to end this broadcast, and in about 5 minutes, Malad will start with his research talk, the first of two shorter research talks on the topic of neuromodulation.